Hello, welcome to lesson 13 in our series on learning Python. In this lesson, you'll learn how to check user input and prevent the user from entering data that will make your program go wrong. The name for that is validation. So in this lesson, we will briefly recap what we've learned about conditional structures. We'll discuss what validation is and how we can use conditional structures to make validation in our programs. And we'll also learn another method, a new method called exception handling. So let's just briefly recap the conditional structures that we have learned. We've learned to use if and else, elif and nested if structures. Validation is a way of checking user input before the program proceeds to process that input. The reason to include validation in our program is to prevent errors caused by the user entering the wrong data. How do we know that they've entered the wrong data? Well, we plan carefully with a set of criteria that are called validation criteria. Validation criteria means the standards that we want the input to meet before we will use it in our program. There are a number of different ways that we could do this. For example, we could check that the data is of the right type. For example, if somebody's going to enter the number of children they've got, that's more or less got to be an integer. It can't be a fraction and it can't be a letter. We could have a range of allowed answers. So if somebody's entering the number of children they have, there's an upper limit, but also it couldn't be a minus number. We might simply have a list of valid answers. So for example, if somebody's buying a train ticket, we might have a list of places that you could go to by train, and they'd have to pick an answer from that list. And another kind of validation criteria that you might have come across is where we check that the data is present before we go any further. So for example, sometimes you can't go on to the next screen of a program until you've filled in, let's say, your email address. There are some others. Those are 4 quite common ways of validating data. So here's an example where we're asking the user to enter the month's number, and then we're using an elif structure to turn that number into the name of a month. So if they enter 1, the month is set to January. If they enter 2, the month is set for February. And this is quite a good use of the elif structure. But what if they give a number that is not a valid month's number, like 13 or -2? Well, we can easily fix that because right down at the bottom of the elif structure, I've missed out all the other months to avoid cluttering the screen. So we've gone through all the months, and then we can have an else command. And if the person hasn't entered a valid month's number, then we could display a warning message to tell them, and then we can just set the months to a value such as January. It's usually a good idea to do that because you're probably going to be using that value, the month's name, elsewhere in the program. Otherwise, why would you have this structure at all? So it's often a good idea to have what we often call it a default value, so that if the user doesn't successfully set the month, it defaults, in this case, to January. So let's just recap what we've seen so far about validation. We must decide on the validation criteria. So for months, it's got to be a number from 1 to 12. Or if it was email address, we might say, oh, well, they have to fill in the email address before they can carry on. In any case, we use logical tests and the conditional structures that we've learned about to catch invalid data, to spot when the data doesn't match our criteria. And the things that we can do include showing an error message on the screen using the print command and setting default values if the user hasn't managed to set a value. Later on, when we learn about loops, we can also use a loop. So we could make it loop back to the start and give the user another try at entering the data. Anyway, that is how we can use conditional structures to help to prevent the user from spoiling the program by entering the wrong data. But some user errors are more serious than that. Sometimes the user can enter data that is so wrong that it makes our program crash. So here's the same program that we were looking at a few minutes ago. Let's concentrate on that line. The user has to enter a month's number, and then the second line of the program converts that input string into an integer. This is a really common thing that we have to do in Python programs. But if the user enters a value which the computer can't convert into an integer, that can make our program crash. So let's have a look at an example. Here the user has misread the instructions, and instead of entering the month number, they've entered the month name, June. Let's see what happens when they press enter. The program crashes and an error message appears. Basically, what it's saying is it doesn't know how to convert the word June into an integer. That's not something that a computer can do. And an error like this is very serious because the rest of the program simply won't run. So how can we prevent it? Luckily, Python offers a good method for preventing the type of user inputs that can crash our program, and it's called exception handling. The diagram here shows the general outline of this structure. The first line is a header, which is just the word try followed by a colon. The next line will be indented, and on that line write the command that might go wrong, the command that can cause your program to crash. So in this example, it would be the line that tries to convert the input to an integer. Try and keep the number of lines there down to an absolute minimum. I think one line is the best. Then we have another header, which is the word except followed by a colon. And the line that follows that is the alternative. It's what you want the computer to do if the first command goes wrong. So they try the first command, the computer tries the first command, but if it doesn't work, it does the alternative command. But let's have a look at an example. So let's look at how we would use exception handling to fix the problem in the month program that we were just looking at. First of all, the user enters the month's number. Then we try to convert it to an integer. But if that fails, instead of the program crashing, instead it will show the message that's not a valid number, and then we'll set it to a default value, let's say 1. Again, as we saw before, it's a good idea to have a default value that the computer will use if for some reason the user's input goes wrong. This program now will run without crashing whatever the user types in. So let's recap exception handling. We use the exception handling structure when we're concerned that the user input might make our program crash for one reason or another. We try the command that could be problematic, and we give an alternative which the computer can use if the first command doesn't work. So you've learned 2 different ways to catch bad input from the user, and we collect these together under the general heading of validation. Here are the 3 programs that you were asked to do last time. So instead of giving you new work, unusually this time I'm going to ask you to revisit the programs that you wrote last time and add validation or exception handling so that bad input by the user doesn't make your program crash. Okay, so there'll be some exercises in the next lesson, so I'll see you then.